Quadratic functions. A quadratic function is a function f of x equals ax squared plus bx plus c. Notice that it is a second degree polynomial function. The a, b, and c here are real numbers, and a cannot be 0. And the reason for that is because if a is 0, then this term doesn't exist. And if that term isn't there, then this just becomes a linear function. The domain of a quadratic function is the set of real numbers. So you can plug every number into a quadratic function. Now that same quadratic function can be written in a different form called standard form. So here's the original quadratic function. It can be rewritten by completing the square into the following format: a times x minus h quantity squared plus k. Again, this is standard form. The graph of this function is what we call a parabola, and the vertex of the parabola, which is the center point that you see on the graph here, is given by the point hk. So h and k are given by what you see here. If the number a is positive, the parabola opens upward, and the vertex is a minimum value of that parabola. And if a is negative, the parabola opens downward, and the vertex is a maximum value of the parabola. Okay, so I know that's a lot to take in, but we're going to do some examples of graphing parabolas that are both written in this form and also in this form. And then we'll do some applications as well. So the first method for graphing, if it is written in the form ax squared plus bx plus c, what we're going to do is go ahead and find the y-intercept by letting x equal 0. And if you do that, you will always get y equals c. So this number that you see on the end here, that is always going to be the y-intercept. And then the x-intercepts, you can get that by taking ax squared plus bx plus c and setting that equal to 0. And you can solve for this any number of ways. Of course, you can use the quadratic formula, which is what is indicated here, but you could also use factoring if possible. And then the vertex is going to occur at the number x equals negative b divided by 2a. So that's a formula for finding the x-coordinate of the vertex. And then we'll talk about how to graph parabolas using the second method. So this is when you write the equation in so-called standard form, where you can look at the vertex by simply observing these numbers here. So let's go ahead and take a look at some examples. So in the first example, we want to sketch the graph of the parabola y equals x squared minus 6x plus 5. So first, let's go ahead and find the y-intercept. Now you don't have to memorize this. To find the y-intercept, you simply let x equal 0. And if we plug in 0 into the equation here, we get 0 squared minus 6 times 0 plus 5, which is equal to 5. So again, the y-intercept is always just the number on the end here. Now for the x-intercept, to solve for that, we are going to let y be equal to 0. So we're going to put 0 in here. And doing that gives us 0 equals x squared minus 6x plus 5. And this is an equation that we can solve by factoring. And then we're going to set each one of these factors equal to 0. And of course, we get two solutions, x equals 1 and x equals 5. So let's go ahead and graph these now. So the y-intercept was y equals 5. So that means it's going to hit the y-axis at 5. And the x-intercepts are x equals 1 and x equals 5. So x equals 1 is here, x equals 5 is here. Now to graph the parabola, you must have the vertex, okay? So to get the vertex, there's a couple of different ways to do that. One way to do it, of course, is to just use the formula. So the formula for the vertex is always going to occur at x equals negative b divided by 2 times a. Now, this is equal to negative negative 6 divided by 2 times 1. So if you're wondering where I'm getting these numbers from, remember the number in front of x squared is a, the number in front of x is b, and of course this number here is c. So when we say it's negative b divided by 2 times a, we're plugging in the numbers b and a that you see here. So now if we do the math on that, negative 6 is 6 divided by 2, which gives us a value of x equals 3. Now I also want to point out that if you look at the graph, you can see that we have an x-intercept at 1 and an x-intercept at 5. The vertex is always going to occur at the x value that is exactly halfway in between the x-intercepts. So of course the number that is halfway in between the x-intercepts is x equals 3. So that's a little bit more of an intuitive way to get that value. Okay, now how about the y-coordinate for the vertex? Well, to get the y-coordinate, you simply take the x-coordinate, which is 3, and you plug it into your equation here. So if I plug in x equals 3 there, we get 3 squared minus 6 times 3 plus 5. This is equal to 9 minus 18 plus 5, which gives us y is equal to negative 4. So the vertex occurs at x equals 3, y equals negative 4. And as soon as I have these points, you can very clearly see that the parabola must have a graph that looks like this. So we'll go ahead and sketch that now. And this is not a perfect graph, but it is good enough. Now I would like to point out a couple of other things about this graph. So we did say that the domain of a quadratic function is all real numbers. So you can plug in any x value that you want. But the range is not all real numbers. Remember, the range is all the y values that you get from this graph. And you can see that we do not get any y values below negative 4, right? So the range starts at y equals negative 4 and goes up to infinity from there. And also this point right here, the point 3, negative 4, which is also the vertex, is the minimum value of this graph, right? It's the lowest point on the graph. Okay, and so those are just some graphing basics for parabolas. Let's take a look at some more examples. So very similar in this problem, let's graph the parabola that you see here. So again, for the y-intercept, the way you do it is you just let x equal 0. If you plug in x equals 0, these terms are going to go away, and you end up with y equals 3. So the point 0, 3 is the y-intercept, that's right here. Now for the x-intercepts, we are going to let y be equal to 0. If we let y equal 0, we get 0 equals negative x squared minus 2x plus 3. Now to solve this, I can use the quadratic formula or I can use factoring. I prefer factoring when it's possible. So let me first multiply both sides of this by negative 1. That's going to give us 0 equals x squared plus 2x minus 3. Now the reason I did that is because I don't like factoring with a negative in front of the x squared. So if I multiply both sides by negative 1, it gets rid of that negative. Now we'll go ahead and factor it. We have 0 equals, this is x plus 3 times x minus 1. And if we set each one of these equal to 0 and solve, we get these two values. So x equals negative 3 and x equals positive 1. So x equals negative 3 is right here. X equals positive 1 is right there. Now we do know because it has a negative in front, we know that this parabola should open down, right? So the graph probably goes something like this, but we must have the vertex. Okay, you cannot graph a parabola without graphing the vertex. So to get the vertex, so once again, I know that the vertex is going to occur halfway in between the x-intercepts, so it should be at x equals -1. But just to double check that, we'll go ahead and use the formula for the vertex. So if we do negative b, in this case that's -2, divided by 2 times a is -1, right? So that's a and that's b. And this is 2 divided by -2, which is -1, which is what we expected. And now the y-coordinate, to get the y-coordinate, we have to plug x equals -1 into our equation. So we're going to get, very carefully now, negative, and then -1 squared minus 2 times -1 plus 3. And this is negative. -1 squared is 1. Minus 2 times -1 is plus 2, and then plus 3. And this is -1 plus 5, which is positive 4. So the vertex occurs at the point x equals -1, y equals 4, which is right here. And then we can sketch the graph. All right, and there it is. And once again, the domain for this graph is all real numbers. But what is the range? Well, in this case, there is a maximum value up here. So the highest y value that we can get is y equals 4. We cannot get anything above 4. So the range is going to be all values from -infinity up to and including 4. Now for this next one, same thing. Let's go ahead and graph the quadratic function here, the parabola. Now this time I'm going to take a slightly different approach. I'm going to go ahead and find the vertex first. To get the vertex, we have x equals -b divided by 2a, which is -6 divided by 2 times 3. This is 6 divided by 6, which is 1. And the corresponding y-coordinate will be 3 times 1 squared minus 6 times 1 plus 1. And this is going to be -2. So the vertex occurs at x equals 1, y equals -2, which is right here. Now we do know that a is positive, so this parabola is going to open up. So we know that it goes something like this. We also know that this number is the y-intercept. So y equals 1 here on the y-axis is the y-intercept. So now how about those x-intercepts? So to get those, we have to let y equal 0. And if we let y equal 0, we end up with 3x squared minus 6x plus 1 equals 0. This is not factorable. Okay, you can try to factor it, but it does not work. So I'm going to solve this by using the quadratic formula, which is -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And so this is 6 plus or minus the square root of, this is 36 minus 12. So that's 24 over 6. Simplifying, we get 6 plus or minus. Now, to simplify the square root of 24, you can factor out 4. Square root of 4 is 2, so you get 2 square root of 6 divided by 6. Canceling a factor of 2, we get 3 plus or minus the square root of 6 divided by 3. And this is two numbers, but these numbers are going to be decimals, okay? So if you plug this into a calculator, 3 plus the square root of 6 divided by 3 is going to be approximately 1.8, and 3 minus the square root of 6 divided by 3 is approximately 0.2. So if you graph these, that means that you have an x-intercept at about 0.2 and at about 1.8. Now you can do that, but a better way to do this would be to realize that there's symmetry when you have a parabola. So we know that whatever the shape of the graph that looks like here, there's going to be a mirror image on both sides of the vertex. So if this is the line where the vertex is, we know that on the other side here, it's going to pass through a point that has the same height as this point, right? So you don't actually have to have these to get a good graph. You can sketch a graph without it. It's just that your graph won't be precise. And that's okay. So for right now, all we're doing is we're just trying to, get a good grasp on graphing these parabolas by finding the x and y intercepts and by finding the vertex and sketching as nice a graph as we can. All right, so for this next one, same idea. So let's go ahead and go through it. To get the vertex here, x is going to be -6 divided by 2 times -2. This is -6 divided by -4, which reduces to 3/2, which is the same as 1.5. The y coordinate, now when I plug in the x value, I'm going to actually plug in 3/2. It's a little bit easier to plug in. -2 times 3/2 squared plus 6 times 3/2 and then -5. So this is -2 times 9/4 plus 6 times 3/2 minus 5. Now we'll do a little canceling. 2 goes into 4 2 times. So this is equal to -9/2 plus, now right here you could cancel, but let's go ahead and keep the 2 there because that way we'll have a common denominator. So 6 times 3 is 18 over 2. Minus 5, and 5 can be rewritten as 10 divided by 2, right? So getting our common denominator there, we have -1/2. Right? We have -19 over 2 plus 18 over 2 is -1 over 2. So the vertex here occurs at x equals 3/2 and y equals -1/2. Okay, that's our vertex. And so 3/2 on the x-axis is 1.5, and then -1/2 is right there. So that vertex is going to be right there. And I'll put a V for vertex here. Now, here's the thing. This parabola opens downward, doesn't it? Because it has a negative in front. So that means the shape of this parabola goes like this. So now let's think about that. If this is the vertex and it opens downward like that, you can see that it's not going to hit the x-axis, is it? It's not going to cross the x-axis. Now, we'll still have a y-intercept of -5, okay? So it's going to hit the y-axis down here. And if I go the same distance, so here we are at 1.5, if I go the same distance in the other direction, we will have a point here. And so this graph is going to look something like this. There are no x-intercepts. Now, what if you tried to find the x-intercepts? So, of course, to do that, you would let y equal 0. And if you let y equal 0, you would get 0 equals -2x squared plus 6x minus 5. Now, I would multiply both sides by -1, just because I don't like having a negative number in front of my x squared. And then I can use the quadratic formula to solve for these x-intercepts. Okay? So there it is. Plugged it into the quadratic formula. Simplifying, we have 6 plus or minus the square root of what? Well, this is 36. And then here we have 4 times 2, which is 8, times 5 is 40. So we have 36 minus 40. That's -4. So that's an imaginary number. That's 6 plus or minus 2i divided by 4, which is the same thing as 3 plus or minus I divided by 2. This means that there are no x-intercepts. Okay, because to have an x-intercept, it has to cross the x-axis. And that means that the x-intercepts have to be real numbers. So if you try to find your x-intercept and you get imaginary numbers, that means the graph does not cross the x-axis. Now, of course, we already knew that because of our discussion here earlier. but I want to explain to you that this is what will happen if you try to find them. Now for an application. A company selling copies of an accounting program for home computers finds that it will make a weekly profit of P dollars from selling X copies of the program. According to the equation, P of X is equal to this. Now this is a quadratic function, okay? How many copies of the program should it sell to make the largest possible profit? All right, let's think about this. If you graph this parabola, you know it is going to be a parabola that opens downward because it has a negative number in front of the x squared. This means the highest point on the parabola will be the vertex. And this vertex, in this case, will be the maximum value, right? So if you want to find the largest profit, the maximum profit, you need to find the vertex of this parabola. So basically, in this problem, they're just asking you in a fancy way to find the vertex. So let's go ahead and do that. So to get the vertex, you know the formula, right? X is going to be equal to negative b divided by 2a. That's going to be negative 27, right? That's b. Divided by 2 times a. A is negative 0.1. And so this is negative 27 divided by negative 0.2. And if you do the math on that, you should get 135. Okay? So what does that mean? Remember, X is the number of copies of the program that you're selling. So that's not the maximum. That's how many copies you need to sell to make the maximum. The maximum is going to be taking that number 135 and plugging it into your profit function. So P of 135 is negative 0.1 times 135 squared plus 27 times 135 minus 500. And if you use a calculator and do the math on this, you will get 1,322.5, which means $1,322.50. So how many copies should you sell for the largest profit? You need to sell 135 copies. And what is the largest possible profit? It is this amount of money right here, $1,322.50. In the next example, an art supply store finds that they can sell X sketch pads each week at P dollars each. According to the equation, X equals 900 minus 300 times P. Graph the revenue, R equals X times P. Then use the graph to find the price P that will bring in the maximum revenue. Finally, find the maximum revenue. So this is kind of like the last problem, except that we need to set up the equation for the revenue. Now that's not too difficult because we know that R is equal to X times P, and we know that X is 900 minus 300 times P. So if X is equal to this quantity, we can take that and substitute it into here. And that's going to give us R is equal to 900 minus 300 times P, all multiplied by the P that you see here. And so this is equal to 900 times P minus 300 P squared. So if I write that in sort of standard quadratic form, we're going to have negative 300 P squared plus 900 times P. So this is our revenue function. And then to maximize this, we need to find the vertex, right? Because this is just another parabola that opens downward. So in this case, the coordinate for the vertex will be P equals negative 900 divided by 2 times negative 300. And this is negative 900 divided by negative 600, which is 1.5. Okay, so P needs to be 1.5. Now keep in mind that P is the price, right? So it's $1.50. If you want to maximize your revenue, you need to charge $1.50. Now, what will be that maximum revenue? Well, for that, we're just going to take this value of P and plug it in. So the revenue will be negative 300 times 1.50 squared plus 900 times 1.50. And if you do the math on that, you get $675. Okay? So what that means is you're selling these sketch pads. You need to sell these sketch pads for a price of $1.50 each. And if you do that, you will maximize your revenue of $675. And for our final example, at the 1997 Washington County Fair in Oregon, David Smith Jr., the Bullet, was shot from a cannon. As a human cannonball, he reached a height of 70 feet before landing in a net 160 feet from the cannon. Sketch the graph of his path and then find the equation of the graph. Okay, so I have a picture of the graph here. Basically, we're going to assume that the cannon is situated at the origin, and the human cannonball is fired into the air, reaches a maximum height of 70 feet, and flies a total distance of 160 feet from the cannon. Now, we know from symmetry, since this is a parabola, we know that halfway, which is at 80 feet, is where he reaches his maximum height. So basically, we know the vertex of this parabola must be the point 80, 70. So now we want to come up with an equation for this graph. So we know that y is equal to ax squared plus bx plus c, or y is equal to a times x minus h squared plus k. And for this problem, we're going to use the alternative form here for the equation of the parabola. Because we know that if the vertex is at 80, 70, this is where h equals 80 and k equals 70. So we can take these values and plug them in here. And that's going to give us y equals a times x minus 80 squared plus 70. And you'd think that we're done, but there's one more thing we have to find. You see, the equation of the parabola is not complete until we know what the value of a is. Now, we do know that a is going to be negative because this parabola opens downward, right? So we know that a is negative, but what is the value of a? Well, to get that, all you have to do is plug in any other point besides the vertex on this parabola. There's two other points that we know. We know this point right here has an x-coordinate of 160 and a y-coordinate of 0. And we know that this point right here has an x-coordinate of 0 and a y-coordinate of 0. You can actually plug in either one of these points. I will plug in the 160, 0 point. Okay, so the point 160, 0 means x equals 160 when y equals 0. And I'm going to plug this in. That's going to give us 0 equals a times 160 minus 80 quantity squared plus 70. And this is 0 equals a times 80 squared plus 70. 80 squared is 6,400 multiplied by a plus 70 is equal to 0. Now, if I solve for a, I can subtract 70 and then divide by 6,400. And when I reduce that, I get negative 7 over 640. So the final equation of this parabola is that we're going to take this value and put it in for a here. And when you do that, this is the resulting equation. Now, what does that mean when you have this equation? Well, it means that you can find any other point on this path, right? So if you wanted to know how high was the human cannonball when they were at this value of x, so when they traveled 120 feet horizontally, you can plug that in, and that would give you the height, okay? So all I would have to do is let x equal 120, for example, and then solve for y here, and then that would give us the height of the cannonball at that point. So once you have this equation, you can basically find any point on this path. And that concludes this video lesson.